All right, class, let's go with it here. So these are homework questions here. 6.1 due today, is that right?
6.2.
6.2 due today.
Yeah,
Okay.
that question is gonna be Monday.
Monday, that's right. Okay, let's go back to 6.1 real quick here with a couple questions. 17 is what we're looking at. Let's see. Let's see how this erases it well. No. Okay. All right, I don't have these marked, so I have myself a sine theta minus 3 is equal to 5 sine theta. And it says, first of all, find all degree solutions. And then from 0 to 360, but not getting to 360. So anything less than 360. Cool. Okay, so first things first is algebra. We have to solve this guy. So I'm going to have to go like this. Okay, it says use a calculator to approximate the answers to the nearest tenth. On the previous section, it says give exact answers. So you know we're going to have to use a calculator here. So I got myself 4, that one. Everybody good there? Sine theta is equal to -3/4. Okay, and we have ourselves this discussion again, which is okay to have again. We're still learning. So if your calculator, the way you do it on a calculator that works all the time, good? That's probably the best way to say it, is, Annette, ready? What we do is we drop the negative from all the stuff. And what we do is we just get the angle in quadrant 1, we get a reference angle. Once we get a reference angle, then we do all those stuff we want to do. And so what we do is we change this from, let me show you, instead of the chicken scratch here, we change this from sine theta is equal to -3/4. What we do is we change it to sine hat theta is equal to +3/4. Good. That's the change. I'm declaring that I'm just going to look at a reference angle only. I'm not thinking about the angle itself. And then I say theta hat is equal to the sine inverse of 3/4. Anybody help me with that one? Well, you guys don't have your homework, huh? I collected it.
The fee 48.5 or 48.6.
All right.
I know.
40.6. Okay, cool. And that is the reference angle, right? Reference angle in quadrant 1 is a 48.6. What we want is, we want all the negative values of it. Whoa, what is that? Like this. That's cool. Okay, so for y to be negative, it has to be here, and it has to be here. That's what I'm looking for. So I'm looking at 48.6 degrees as a reference angle in quadrant 3 and in quadrant 4. So then that angle would be 180 degrees plus 48.6. Whatever that's going to be. And in quadrant 4, it's going to be 360 minus 48.6. That's what we do to get angles there.
Why is the first one 180% off 360?
Because if you kind of think about it here, to get this angle, we have a half rotation already on our hands, and then we just need to figure out how much more we have.
Oh, okay.
For quadrant 4, what we have is this. We have ourselves, hey, look, the reference angle is always going to be the x-axis. We're good. And so in this case, if we're trying to figure out that one, we're saying to ourselves, hold on, to get to the x-axis, I'm going to already be at 360, but I want to go backwards, so I'm going to be subtracting.
Oh.
Ooh. Real quick, just to give us the relationship between them. Annette, is that good for that one? Okay, quick relationship between reference angle and angles. In quadrant 1, theta is equal to theta hat. All good? In quadrant 2, theta is equal to 180 minus theta hat. So so the triangle here is exactly the triangle here. The triangle here and the angle is you're trying to form this angle here. And reference angles are always reference to the x-axis. So if the reference angle is always to the x-axis, that means you're saying, hey, look, I have a little bit too much angle right over here. I have that much more angle than I need. Okay, to give us this one, it's going to be, yeah, it's going to be 180, and then we need some more. So this is 180 plus theta hat. We're just adding more to it. And then this one is, we don't want to add too much. The reference angle is too much to get there, so we subtract it off. Okay, does that help? Yeah, no. Okay, and I'll let you finish that one off. Okay, 6.1, 33. Jam. That is so cool. Use the quadratic formula to figure. Oh, hold on, guys. Sorry, real quick here. And then just to finish it off here. So whatever answer this is, anybody, what is the answer here? 128.6, 228? Cool. Okay, so that is to answer part B. Part A says I want all of the angles in the whole entire universe. They give us this. So you can just keep on rotating positively forever. You can keep on rotating negatively forever. And so to finish up A, it's going to be 228.6 degrees plus 360 degrees K. That'll give us all the rotations for the angle in quadrant 3. 311.4 degrees plus 360 K. That'll give us all the rotations for the one in quadrant 4, where K is an integer. In calculus, you guys will see that we use K. K then starts to be, K is a whole number. We actually want 0, and then we want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then keep on going. We want the positive values only, not the negative values. Sometimes we even use integer values. We don't, sorry, integer values. We use whole numbers, counting numbers, or natural numbers, because we want to start with 1 and then count forward. So 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, now we're good there. The A and the B part to it. Cool. You guys, that's cool. Okay, use quadratic formula to finish off this guy. 2 sine squared theta, then put it down, minus 2 sine theta minus 1 equal to 0. Find all degree solutions, find that one, use a calculator if need be. Okay. I'm going to just see if I can factor this without the quadratic formula. Let's just see if it works. So the only way I can get a 2 sine squared theta on the front end is if I'm multiplying a sine theta with 2 sine theta. I think we might just be able to. Let's see. Can or can't? So the only way to get a -1 is a +1 and a -1. That's the only way. That's a -2. Yeah, we got that little. If this was a -1, it would have been fine, right? Got it. Formula it is. Okay. So what I usually do is I go like this right here. I just cross off the factoring process. Like that doesn't work. And sine theta is equal to, quadratic formula says -b. So this is my A value, B value, C value. So opposite of B, plus or minus the square root of B squared minus 4AC all over 2 times A. All right, this is 8 positive now, 12. Are we okay with 12 there? 4 times 3, which means we get to pop out a 2 on the outside, 4 on the inside still. And then these guys reduce by 2 here everywhere. 2, 2, and 2. So 1 plus or minus √3 over 2 is what I have. Okay, that's the first part. Second part is we're solving it for sine. So sine theta, and the best way to do it is to split it off into 2 different pieces, because we have 2 different things happening here, like that and that. So we're going to use a calculator, of course. So can you guys do 1 plus the square root of 3 divided by 2? And what's the number itself before we take the sine value of it?
1.37.
7 blah blah blah, right? Cool. I'm gonna write this. There's no solution for this guy. I already know. Does not work, absolutely, because it's above 1. It wouldn't work if it was below -1. That's what happened on our lecture problem, right? It was less than -1 on that one. Okay, cool. Let's go the other way here. So this one, sine theta, and just to give a rough estimate, 1 minus the square root of 3 divided by 2. What is that? Oh, yeah, 1 minus the square root of 3 divided by 2.
It's negative 0.37.
Okay, gotcha. Okay, guys, real quick here, let's pay attention because I know I don't do that much work on calculators, but let's work this one out through. So first things first is we probably, if you're going to approximate this, you're probably going to leave 5, maybe 6 decimal place accuracy if you want to get a good angle on here, okay? And again, if it's dealing with other issues in the industry, then you're going to leave more. We're good. But you need at least 5, maybe 6 decimal place accuracy. Second thing is notice this little negative. We just talked about it. Negative, I don't want that. I want the positive value because I'm going to change it to a reference angle. So let's change a few things here. Let me actually get out of here just for a second. So lots of work here right now. So 1 minus the square root of 3. Enter, divide by 2. I get myself a negative 3 points. So 0.1, 2, 3, 4, 5, 6. In fact, I'm even going to grab the 4. I'm going to grab that little 4 because this guy's a 0. So 0.3660254. That's what I'm going to grab. Sine theta is negative 3.660254. I'm going to grab all that because the next one's is another 0, and that gets you an extra little placeholder accuracy. So then I'm going to switch this up, and I'm going to say, whoa, sorry guys, I'm on 0.3. My point's in the wrong spot. It's this one here. There it is. 0.3660254. There it is. Okay. So now the question is, what is sine inverse of 0.3660254? Yeah, 21.47. So 21.5 degrees is my reference angle. So that's cool. I set it up. In fact, this is very similar to what we just had before. 21.5 is my reference angle. What we want is we want that one right there. So theta is 180 plus 21.5. The next theta in quadrant 4 is 360 minus 21.5. And what do we get there? I'll let you finish it off at that point. Okay, let's jump to 6.2. 45, 53, huh? Okay, 45. Hey, all right. This is the honors question, is that right? And this has to do with what we kind of mentioned last time, which is blood flow in the veins. So when arteries break off or branch out, they branch out in such a degree that it actually minimizes friction with the blood flow coming off the side. That's kind of pretty cool. So in the human body, the value theta makes the following expression 0. Is the angle to which an artery of radius 1 branches off from a larger artery radius r to minimize the energy loss due to friction. So that the following equation is 0 when da 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 da. Whoa, crazy stuff. Oh, so I have this equation. So we're just verifying an equation here. So this right here. That's like crazy. There's, yeah. So lower the uppercase r is the radius of the big artery, and lowercase r is the branched off artery. And then the angle measurements that make that true is, it says this, it says to minimize energy loss, show that the following expression is 0. So this guy is going to be equal to 0 if or when cosine theta is equal to r to the 4th power divided by large R to the 4th power.
Is the radius of the larger and smaller one? Yeah, basically.
Yep, R is any variable, so we can, our arteries could be as huge as we like, as small as we like.
So why is it R4 over small R4 over big R4? Because
That's the thing, like, if cosine.
oh, then, okay, that's just, we're assuming that.
Mhm.
So, when you take out
Let's see. So we're gonna eventually substitute something in here, right? Because if this is true, then the rest is true, right?
so you're saying put that in.
Yeah, we're gonna put it in somewhere. We should put it in somewhere so that
The only
it's gonna
spot
cancel
cosine
everything.
Goes on top of cotangent, which is just
You can multiply by R4 and then you have lowercase r4 equals that and put that in. And you only have to take R.
Say that again, Abe.
If you have, if the cosine equals little r4 over big R4, can you multiply by the big R4 and get little R4
Okay.
equals and then
So-
plug in little R4?
Seeing that right there? Yeah, absolutely. And then there's only one little R4, which is right there. Everything else is big R4. So let's substitute. This guy becomes R. So this guy just got substituted in as R to the big R4, cosine theta. And the rest of it just follows. This is just still this. That's still this. That. And we said it's going to equal 0 eventually.
I exactly on R2.
R squared gets factored out.
Hold on, you're doing the thing where you're letting me go in the wrong direction.
He's like, I really think that every single time now.
Okay. Let's see, R squared gets factored out. I'm left with this right here. This would be like 1 over sine squared. Can we just do that at least? That. This is 1 over sine. This is sine over cosine. Is that, are we getting somewhere maybe? So I got a few things here. I got this and this gone. Is it that sine and that sine is gone?
Wait, it's cotangent, not. So the signs don't cancel.
Cotangent. Cosine over sine. Thank you for catching that. Now we have a sine squared on our hands.
Is this not the right direction?
I don't know. Where is it going?
Wait, don't you have cosine over sine squared theta minus cosine over sine squared theta,
Yeah,
which is r?
0.
Yeah, because it's r squared times 0
Yeah.
times r squared, which is 0.
It worked.
I hate these problems because I never did it if I was doing it on my own.
I know.
Class, like you suggest one right thing.
Are we good there? I haven't finished it off. Are we good there as well?
Yes.
Okay.
Yeah, I was never gonna take that, no matter how long I stayed in that math problem.
Okay. Okay, and one more here, 53. Finish off the
Isn't
home.
that just, isn't the R squared on the bottom one too?
Yeah, it doesn't actually matter.
No, no, it doesn't matter. Okay, I missed something.
R squared right here, right?
Yeah.
Okay, tell me how you finished it off though. What happened?
Well, it's cosine theta over sine squared theta minus cosine theta over sine theta. Oh, hold up, there's the R thing.
There's a R squared though.
Okay.
That doesn't help. Thought it helped.
Just divide by R squared and we don't have. Yeah.
Abe, we found out that this guy has an R squared. This one doesn't, so you can't put them together because there actually has a multiplier that's not the same.
Whoa.
All right, this one is an R squared.
R squared on the one of them, so you can't actually subtract them.
Oh, yeah, darn it, darn it.
Yeah, they're not like termed anymore.
Oh, well, they did,
Mm-hmm.
yeah. Wait, now I get to put the R squared back in. How?
I mean, if you do,
You just,
you have R to the fourth minus R to the second, but actually, no, that doesn't even
Mm-mm.
you have to just divide it in parts, but this is a four.
Again, there's a reason I didn't try and do it for the reason. If you get, yes, if you get R squared out, everything in parentheses is zero.
Yeah, so we managed by doing this right here, we at least got little r out of the way. So little r is no longer there, so that kind of helped to simplify.
Was that the right way to start it? Do you think, or should we run something else?
I think so here, because it's an expression, right?
Yeah.
We're just trying to make it go to zero eventually. It says if this is true, then this whole expression should go to zero.
What if it's not true? What if you just say?
What's their line?
Or if you should, like, divide of. The R squared on the other side, the R squared on the outside and the other side. Is multiplying inside the R squared.
Oh, yeah, no, so this is non-existent yet, right? Because we don't have an equal sign yet. We're just saying eventually this is going to equal zero. Right, it says if show that the following expression, so this is the expression right here, is zero when cosine theta is equal to r to the fourth divided by r to the
So
fourth.
either R squared is zero, or everything inside of the parentheses is zero. Because one of those has to be zero for this whole thing. But what I'm saying, if, right?
Mhm.
It
So-
can't be though.
So don't they
So-
both? They can both.
No, if R squared is zero. I guess, yeah.
Well, if R squared is zero, then R four is zero, right? That's wrong.
Yeah.
No, R squared can be zero, though, because then R to the fourth would be a zero and S is not.
Mhm.
So it has,
I think we're stuck.
do you know what to do?
Uh-uh. So let me think about it. I gotta think about it some more. Tristan, let's go for it.
Does the textbook have an answer?
Say again?
Does the textbook have an answer? I didn't look at it.
Oh, yeah, let's see. This is 45. I'll have to think about it some
Give
more.
me an answer, that's not the, well, I didn't look for it,
Uh-huh.
but
6.3?
6.2.
6.2, okay. That's funny. It says, see the instruction solution manual, which we don't have.
Oh, no.
So this is, I'll put a star. Let me think about it for a little bit longer. That's fun. Okay, cool. Love it when I get to the ones I can't solve, but then I can think about it. I had like 2 problems in calculus that way. Like, I can't, why is that not working? So I thought about it for a day and a half.
You got it?
I got it. Yeah, like, okay, that's why.
Like,
Okay.
Always the things that I messed up. And I hate it every time. It's like, not that I didn't know what I was doing, it's just a negative. That's the.
Yeah, I did that on the practice test, and so I was like, I better not do it on the actual test. I don't think I did.
Easy about 53 as well. So let me think about 45 because it's a fun problem, but I'll do 53 here. So we got this on our hands here. Probably is going to be a long problem.
Yeah, as long as you're doing it.
I got that.
You get it wrong.
So use a graphing calculator. You're going to find all the radian measurements from 0 to 2 pi, not including 2 pi.
So. subtract those.
Oh yeah, here we go. So right, as soon as you sine and cosine in their linear forms, there's no other way but doing that here. So we're going to leave this on that side. Notice this is a negative cosine. That's okay. Once I get the two trig functions on either side, we are going to.
Do you want to add 2 first? Or do you want to-
Oh yeah. Oh, up to you. You can add
It
2.
makes it easier because it's already at 3 sine.
It's going to become bigger. Too big, right? So plus 2 here. And let's see, to make it a little easier to multiply, as soon as Isabel started doing it, I'm going to grab the little negative, put it on the inside. We're good.
3 sine of x is 9 times squared.
Yeah. And the other one is just going to be 4 minus 4 cosine plus 4 sine.
Perfect. Okay, so now I'm thinking I'm going to convert this guy to cosine.
So what
Because
is
of
4
the-
cosine?
Two.
Oh, it's 2 times.
Negative 2,
cosine.
negative 2.
So that's just going to be 9 times 1 minus cosine. Maybe 9 minus 9 cosine. Oh, I see actually. Oh, positive cosine.
Yeah, as we move
Add
across.
Add 9 cosine.
Let's see. I'm going to go cosine first. That okay? I'm going to move these guys together. So 10 cosine x squared.
Minus 4 cosine.
That works by me. Boom.
And then, oh, what is that? Oh, 10 is not 2. 5 and 1. 4 cosine.
What is it minus 5?
Subtracting 9 from both sides. And so,
I
okay.
have a negative 4 for some reason.
Yeah.
I mean,
Yeah, quadratic formula here, but the little rule says use the graphing calculator to solve from 0 to 2 pi. So grab this guy real quickly here. We're going to go with the equation that we have before us.
How do you do cosine squared x? What's your shape equals?
Cosine squared x, So we're going to have to put a parenthesis first around the cosine, then cosine of x. Close off the parenthesis for the x, close off the parenthesis for the cosine, then square it. Now you guys with the T84, what you guys have is it's called pretty print. Pretty print means it's going to actually shift your stuff into the exponent, which is kind of cool to sort of see that. Minus 4 cosine of x minus 5. Boom. And then we're going to graph this guy. And we're going from 0 to 2 pi, right? That's what we want to get to. 0 to 2 pi. So I'm going to go with window going from
You mean radian or degree?
radian mode. Yeah, so we're here.
That error again. What did I do?
Let's see. Let's put it to trig form first, and then we'll go. So zoom, Isabel, if you want to zoom, and we'll put number 7, zoom trig.
What do you mean error, you idiot? I'll let someone else back.
Here, Abe, let me see your calculator because there's something off there. That's all. Exponent, which is supposed to show an exponent, but it's not there.
Oh. Ooh. Yeah.
Wanting an exponent was not there. Okay, so what we have,
That is not way a
Okay.
lot.
still.
And that's a graph. So I didn't know
You're squaring the x instead of cosine. That's what I put to see there. The cosine of the square term.
I don't have a bad phone. I
Yeah,
don't
no.
know why. It's not.
Yeah, we're good.
Ideal. This is a snazzy jacket. I feel like this. Like that.
+5 or -5?
Oh, what's my time? Oh,
Just want to make sure. Here, let me go to mine here, but it was a -5. Oh, it's right here.
wait. I didn't fix that.
So if you're squaring cosine, you just square after.
Nah, I have it.
Cosine 2 and
Yeah, you just start an extra parenthesis,
Square X.
on the beginning part.
Okay, that
Right,
makes
I
sense.
get completely
Mhm. All right, so we were looking from 0 to 2 pi. I think we're looking at these zeros right here. There's 1, 2, 3, and 4. Good there? So we're looking for this guy here. That's 1, 2, 3, and 4. Trying to figure out those values right there. So we are going to, we're going to find our zeros. We good? That's what we're trying to find. Find our zeros.
There's like kind of do that for you, right?
Mhm.
Oh.
It's not, let's see, we're gonna go to calc menu. And so the only thing is, I don't like the fact that it's, let me just kind of zoom in and make it look nicer. We're good. So first things first,
We just see, oh. Okay.
just this piece right here. That's what I want to see. So how about we go to window now, and we're gonna go from, instead of -pi/2, -2 pi going all the way to the other side. Let's go with -pi divided by 2. So it gives us a little bit of a space on that side.
The X maximum.
A maximum would be, let's see, there's 2 pi right here, right? But we want to add an extra pi/2 just to give us a little space. So what's 2 pi plus a pi/2? 5/2, perfect. 5 pi divided by 2. And then I think with the rest, and then maybe because the graph is going up and down like all over the place, let's go out to like -10 to 10 or something, just to give us a little bit more space.
If it's going to.
Good there. Isabel? So here's my graph now. Oh, I like it now. Look at this. Boom. Boom.
What the heck? Where would be Oh, my X scale should be 1, should be.
No, X scale is in pi/2s.
Okay.
Pi/2 is your X scale.
Oh. And then how do we find the 0?
Here goes, guys, real quick here. So we're going to hit on calc menu right here, calc menu, and we're trying to find the zeros. Calc menu zeros, click enter, and then whoa, hold on. Number 2, right? Yeah. Oh, I had value in there. So it's gonna ask for a left bound and right bound. So we're gonna do is go backwards in our arrows, and we can only cross 1 0 in our bound. We good? So be careful right here, guys, real quick here. Notice you're crossing over. It's gonna be that 0 right there.
Oh, there's no actual zeros. Just gets like super close.
But when you get your left bound, when you set up your left bound, you just want to make sure you don't cross any other zeros besides that one. So then you cross that 0, you click right bound, and then click guess.
How do you think like that?
Do you guys use the enter again for?
Enter, yeah, just enter again. So 0.36. There's 1 radian measurement. You got to do the same for all of them. So 2, 3, and 4. So good. Let me do that again. Need for me to do that again?
Yeah.
Yeah, sure. So click on calc menu.
I did that.
So calc,
Sure.
number 2, which is 0. And then what we want to do is we want to be on the left bound. We want to be the left side of the 0, but not crossing any other 0. So about right there probably is the best way to do it. Click enter. And it's going to open up this little parenthesis or arrow on this side right here. Then what you do is you cross the 0 from the left to the right to get you. So as soon as you cross, again, you can go a lot further out. That's fine, but as long as you don't cross any other 0. Click enter. It's going to ask for a guess. And who cares? Just click enter a second time. The T84s, I don't think you guys ask for a guess anymore. Is that right?
Yeah, it does.
Still does, huh? Okay. So just click enter again, boom, and da-da-da-da. They'll do some calculations for you and done.
Ooh, so you want. So you go to right bound there?
Yeah, right down.
Press it again, you have guess.
And then just press the guess again. Technically, the guess should be just you're moving closer to the 0, that's
It
all.
says quit.
Ooh, that's fun. Your calculator doesn't like you today, Abe.
Calculate 0. And it start right here, right? See the cross, go to right down.
So start calculating. Okay, so go to left down. Click enter. Show the little tiny little arrows. Then we'll go right down. Now you're just setting the right down. Click enter. You should see these little arrows. It's gonna only look right here.
Oh, then now I click the bottom.
Yes.
Okay, so
Okay, guys, looks like today was homework day. That's about it here. So
Need to know
we'll finish up.
what we just did.
Say again?
I probably do.
Are we gonna need, is it expected that we know how to do what we just did?
Maybe for Isabel, that's about it.
Join us now.
Oh,
Okay, just so we know where we're at here for the rest of the time, we were in the middle of 6.3, is that right? We did multiple angles. We learned how to do those. And the triple angle is
Oh, wait, yeah.
we found where it is, and then we're going to use k is equal to 0, 1, and 2, right? We're going to do 3 rotations. The 0 is technically your first rotation, 1 is your second rotation, 2 is your third rotation.
Do we need to do?
No homework yet. We haven't even got past 6.3 to actually do the homework yet. So no homework this weekend. We'll come back Monday. We'll finish it off. And test corrections due on Monday.
And 6.2 is due today, right?
And 6.2 is due today, is that right? Yes, correct. Yeah. 6.2 is due today. If you guys want to drop it off, like right at the. And-
Yes, I won't be here Monday, but I already finished my test corrections. Can I get them in now?
Sure, yeah, absolutely. Yeah. Let me just kind of put them in a different spot. Yeah. Thank you. You too. Thank you.
Thank you.
Sure, absolutely, guys. Have a good weekend. See you Monday.